Students in the live, please confirm with a message whether you can hear me clearly or not. Okay, so then let's start with the lesson. Malik, can I have a tute? So today we are starting with, pay attention now. I mean, towards the middle of the class, I'll explain the plan actually, the plan for these days. But to remind you, today we are starting optics. And as usual, we do optics from 3:30 to 7:30. Then from 7:30 to 9:30, we are doing the heat lesson. Pay attention, everyone. From 7:30 to 9:30, we are doing the heat lesson. Those are the two main lessons happening at the moment, but soon, like very soon, we'll be doing the gravitational field seminar, okay? It would be just a one-day seminar. Very soon, we'll be doing the gravitational field seminar too, okay? So the plan for now is we are starting optics today. Then I think today is the third or fourth day of heat, 7:30 to 9:30. Then the gravitational field seminar will happen really soon, okay? First, I have to finish things for 26 batch, the revision class. So we are going to finish things for the revision batch very soon. Then, we have the time to do the seminars, to start the seminars for this batch, okay? So let's start. Pay attention now. Pay attention, everyone. Pay attention. So optics. So, in the waves lesson we learn, okay? In the waves lesson we learn, but you don't need any support from the waves lesson or mechanics lesson for this, okay? You don't need any support from the waves lesson or mechanics lesson for this, but soon after this, as I mentioned, we are starting gravitational fields kind of stuff. Fields, electrostatic fields, all the kind of fields, they need a lot of mechanics, a good clarity about everything, okay? So, okay. Hope you can hear me clearly, right? The sound level and everything. We'll start. Now, like optical waves. Now pay attention now, everyone. Optical waves are the kind of waves that create a sensitivity, a certain sensitivity on the eye, okay? That means whatever the type of waves that our eyes can understand. Last rows, pay attention. Stop talking now. Whatever the kind of waves, okay? Whatever the kind of waves that our eyes can understand, okay? That our eyes can understand are optical waves, okay? Usually from 380 nanometers. In the tute, it's mentioned as milli, but it should be nano. Around 780 nano, but roughly telling, okay, just correct it, it's not milli, it should be nano. Roughly telling, it's almost 400 nanometers to wavelength range of wavelength 800 nanometers, okay? Clear? Roughly the range of wavelength is around 400 nanometers to 800 nanometers, okay? A range similar to this, okay? So within this wavelength range, whatever the waves coming, our eyes can understand. That means our eyes are sensitive, okay? Our eyes are sensitive to the waves in this region, okay? So starting with how are we going to mark optical waves, okay? How are we going to mark optical waves? That's where we start. So an optic wave or a light ray is marked as just like a vector, okay? Just like a vector, not because it is a vector, but this is the usual representation. You have to have a line with an arrow, okay? Which shows the direction, okay? Clear? So there are parallel beams. A bunch of optical rays we call a beam. Bunch of optical rays we call a beam. So this kind of a beam we call a parallel beam, okay? Then something like this we call a converging beam, okay? Something like this is a converging beam. That means a optic wave moving towards a certain point, a converging beam. And another kind of ray, something like this, a diverging beam, okay? This is a diverging beam, clear? So parallel, converging and diverging, okay? So these are different kind of optical beams we can have, okay? I mean, always these kind of things happens due to a certain optical process. For an example, this kind of a wave, this kind of a optical beam can be produced by what? Maybe a concave lens, you know, right? You have a rough idea from all levels, right? Clear? Maybe from a concave lens, a diverging beam can be produced, right? So we are going to discuss here all the properties, okay, on how these things happens, what are the benefits of this, what are the instruments we can create using these mechanisms, okay? What are the instruments actually? The mechanisms would be like the microscope, the telescope kind of stuff, okay? So moving forward, okay? Moving forward, then we have, I mean, I'm just first going through the terms you have to know, okay? Just the words you have to know, okay? So now, like moving forward, there are sources of light, okay? There are like primary sources and secondary sources are not actually sources, okay? What are they? Like the lights, actual lights, okay, bulbs, these are primary sources. Sun, a primary source. That means it actually creates photons, okay? It actually creates photons. It actually creates light photons, okay? A light bulb, sun, something like that, okay? Clear? What are secondary sources? Everything you see. Everything you see are secondary sources, are not actual sources. That means how can you see this whiteboard? How can you see this whiteboard? Light moves here, then reflects. Clear? Light from whatever the source, light moves here, then reflects back. Clear? That's what I see, okay? Light reach here, then reflects back. That's what I see here, okay? So everything around you, everything you see are secondary sources. Clear? Everything you see are secondary sources. Clear? Okay. Then moving forward, okay? Moving forward, these are sources of light, okay? Sources of light. Then we can classify different medium. That means how a medium supports, okay? How a medium supports light, okay? That is the main topic. How a certain medium supports or blocks light. In that case, you don't have to write anything. Everything is included in the book. So let's just go through the points, okay? And these are not very major things, okay? Just things, just we have to know, okay? Not very major stuff. Then, like there are three main, okay? Three main categories of like medium can be classified in three categories, okay? What are they? One is transparent, that means glass, okay? Transparent, that means something like glass. It entirely allows light rays to move. It entirely allows light rays to move, okay? Then things like translucent, like it just don't allow light to pass easily. It would just like allow light, but without a very good clarity. Without a very good clarity. For an example, sometimes you can see these kind of materials used on windows, not actually transparent. You can't see through that window, but I mean it allows certain amount of light to the building, okay? Okay, that a kind of transparent glass blocks you can see around windows sometimes, okay? It allows a certain amount of light which gives enough light for the room, but not entirely transparent. You can't see through that, clear? Maybe even a small bag, a polythene bag. Okay, you see when you use a polythene bag, what happens? Yes, it allows a certain amount of light through that, right? But you can't see clearly what is after the bag, right? Clear? So things like that. Then the last one is opaque. That means it don't allow anything. Opaque. Don't allow anything. For an example, take for an example a wall. Take this wall. Okay, it want a lot light to come from whatever the next to this wall, right? It want a lot light through that. Clear? Okay, it want a lot light through that. Clear? So that's how things happen. Okay. Then moving forward. Okay, moving forward. Talking about now properties of light. I mean, still we are quickly going through the terms that we have to know. Now only we are starting the actual lesson, that is properties of light, okay, which means we usually start with reflection, but reflection is not ideally in the syllabus, okay, pay attention. Reflection is not actually in the syllabus. That means reflection, like they can ask questions, but not mainly in the syllabus. That means they are not expecting us to teach reflection a lot, but they can ask whatever the questions they want to ask. Okay, clear? That's the idea. They can ask whatever the questions they want to ask, but it's not mainly in the syllabus. What is the meaning of that? That means like it was there in O levels. The whole idea about reflection was there in O levels. You even had convex mirrors, concave mirrors kind of stuff. Not even like mentioned in this syllabus, okay? But I mean, everything they assume that you, since you like had a rough clarity from all levels, now they assume that you would know these things, okay? So they can ask whatever the questions from reflection, but not expected to teach in the syllabus, okay? But I'll quickly go through a few points. I'm not going to waste a lot of time on reflection. I'll quickly go through a few points. Then I mean, I'll show you like after roughly going through the points, then after that I'll show you like how, up to what extent they can ask questions, okay? They can ask, and I mean, they can even ask extremely difficult questions here from reflection, okay? But they are not, I mean, it's not expected to be, I mean, they are not expecting us to teach that, okay? That is the issue there, okay? So, talking about this reflection, what is reflection? A light ray reaching a certain barrier, a light ray reaching a certain barrier, light ray reaching a certain barrier and returns. Clear? A light ray reaching a certain barrier, but without moving to the other side, it just returns to the same medium. Clear? This is entirely different from refraction. What happens there is light moves in a certain medium, through the barrier, fall to the other side, okay? Through the barrier, fall to the other side, clear? But here, it falls to a barrier, then returns back, clear? It falls to a certain barrier, then returns back, moves back, clear? Okay? So this is reflection, this is refraction. So here we are going to discuss about reflection, okay? So talking about reflection, I think you know, you had two main laws, okay? Two main reflection laws in the syllabus. What are they? You had two main reflection laws in the syllabus. What are they? And like, I mean, I know like a few people didn't do well in the waves lesson, right? I mean, missed one or two classes, then didn't understood anything after that. Don't let that happen in the optics lesson, okay? I know that usually happens. I mean, this stuff, I mean, happens every year, okay? It's not like you alone like ruining your life. I mean, every year some people do that, so don't worry. But I mean, I know that for sure, like, it's not like mechanics. Waves, you miss 1 or 2 days, then you won't understand anything after that, right? That's the usual nature of waves lesson. That's why a lot of students, I mean, miss the lesson throughout the way, okay? On the way, some students miss the lesson, okay? This kind of stuff happens in lessons like waves. That means our previous lesson, okay? Same goes with optics after a certain point, okay? So you can't miss a class, miss 1 day, then expect to understand everything from the next day onwards, okay? It's not going to happen, clear? You can't miss 1 day, then expect things to happen like very well from the next day onwards, clear? So don't miss classes, okay? Don't miss classes. Same goes with the heat lesson. Don't miss things every day, every week. Try to watch things, okay? Why? I mean, with the gravitational seminar, properties of matter seminar, everything will be moving really, like we'll be finishing the syllabus really fast. Within the next 5 months, we'll be moving through the syllabus very, not teaching fast, but there would be a lot of content. So you miss, definitely I know there are like few students who missed the wave lesson, who didn't do that properly. Now for them, with the optics lesson, with the heat lesson, with the gravity lesson, maybe they have to do waves also. It's not going to be possible, right? Okay, so I mean, so you have to like not miss any class, okay, and just make sure that you are on the track. Clear? Then only you can come to a seminar. Okay, why? Okay, there are 2 lessons happening now, optics and heat. If you are okay with them only, you can come to a seminar, gravitational field seminar, right? Clear? Otherwise, it's going to be too much content. But if you are like, I mean, you don't have to do very fancy stuff. Just follow the routing every week. You come to the class, go home and read the note of it, take 1 hour and do the homework, come to the class. That's all it need. Okay? Clear? Then when there's a seminar, you have nothing else remaining. So you peacefully go to the seminar. Just follow the same steps. Okay? If you miss a class, watch the recording. That's all. Clear? So just make sure that you're not going to miss any classes. Okay? So moving forward, like you knew, there are 2 main laws of reflection. What are they? 2 main laws of reflection. What are they? When light reach a certain boundary like this, clear? If this is the perpendicular line drawn, if this is the perpendicular line drawn to that boundary, if this is the perpendicular line drawn to that boundary, it will reflect back like this, and everything will happen in the same level or in the same plane, we call. Okay? Everything happens in the same level or in the same plane. What is the meaning of same plane? See, everything can be drawn on the board. Everything can be drawn on the board. That means everything happens on the plane that we call this whiteboard. Okay? It's not like it's gonna move like this, then suddenly all of a sudden move like this. No. Okay? It's not a 3D motion. Okay? It's not a 3D effect. Okay? It's 2-dimensional. That means everything happens in a single plane. Clear? The incident ray, the perpendicular line, the reflected ray, everything happens to be in the same plane. Okay? And whatever the incident angle theta is equal to the reflected angle. Clear? Whatever the incident angle theta is equal to the reflected angle theta. Okay? Incident angle theta equals the reflected angle theta. Clear? Okay? So these are the 2 properties of optics. The properties of reflection. Using these reflection laws, we like derive certain theorems, certain properties. For an example, how does an image formed in a mirror, what is the relationship between the object distance and the distance to the image? This kind of stuff we derive using these 2 reflection laws. Okay? How? I mean, if this is the mirror, if there's an object like this, whatever the rays moving from this point, okay? Whatever the rays moving from this point will follow reflection laws. Okay? Whatever the rays moving from this point will follow reflection laws. Reflection laws in the sense, what are reflection laws? Reflection laws would be, if this ray falls like this, it falls with angle 0, right? Here, it falls with angle 0. So the reflection angle would be 0 at the same time. Clear? Reflection angle would be 0. If a ray falls like this with an angle theta, it will reflect back with an angle, the same angle theta. Clear? Okay. Now our eyes create anything based on the rays it receives, not what actually happens. Okay? Clear? Our eyes create an image. Okay? Our eyes create an image based on what we receive, whatever the rays we receive, not what actually happens. That means if your eye is on this side, the eye will receive these 2 rays, right? Your eye will receive these 2 rays, this and this reflected ray. Okay? Eyes will receive this ray and this ray, these 2 reflected rays. Okay? So these 2 reflected rays, when they enter the eye, okay? When they enter the eye, what we are going to do is, what the brain going to do is, it's going to figure out where all they started. Okay? So based on this ray and this ray, it's going to plot things back and figure out, okay, this is where it started. This is where it started. Clear? Based on that, our eyes see an image here. Clear? Based on that, our eyes see an image there. Okay? Our eyes see an image here. Clear? It's going to form an image here. Clear? Okay? So it's not an actual image, okay? We call them virtual images, okay? Nothing there actually. You go behind the mirror and try to see nothing there, right? Clear? It's not going to appear behind the mirror. It's not like that. It's just, it looks like it's there based on these two rays that we receive, okay? So this image is just imaginary. It's just formed there based on what we receive. There's no actual image like that. Clear? Okay? This kind of stuff we can call virtual images. So virtual images you had in O levels, if you remember, okay? I mean, it's a long time after O levels, right? So, so the reflection, so this is the result of reflection and this is where the image is formed, right? So if you see, if this angle is theta, this is going to be theta. If this is theta, this is going to be theta. This is 90, this is 90. This line is common. So these two triangles are actually same, right? These two triangles are actually same, clear? Same angles, same length, everything same, right? So as a result, if this is x, this is going to be x, okay? Clear? If this is x, this is going to be x. That means distance to the object from the mirror, is always equal to the distance to the image from the mirror. Clear? That's why you see things inverted, okay? That's why through a mirror you see things inverted. That means if you have an maybe a letter like this, if this is a mirror, what happens? Now, as you see, distance to the object is equal to the distance to the image, right? Distance to the object is always equal to the distance to the image, right? Clear? So, as a result, this point, if that distance is x, it's going to be formed at a similar distance like x, right? It's going to be formed at a similar distance like x. Clear? Then this point, if the distance to that point is y, it will be formed at a similar distance y, right? It will be formed at a similar distance y. Clear? So then this point will be formed here. This point will be formed here. So as a result, this is what you see, okay? This is what you see. Clear? Inverted, okay? Clear? That's what you're going to see. It's going to be inverted. Clear? So due to these reflection laws and due to these mirror laws, okay, what is the main law related to a mirror? Whatever the distance to the object is equal to whatever the distance to the image, okay? Clear? Distance to the object is always equal to the distance to the image. Clear? And it's gonna create an image like this, okay? Clear? Inverted. It's gonna invert things. Clear? Okay? So if you place something like this, it's not like you're going to see the same thing. You're going to see things inverted due to this effect. Okay. So these are all the knowledge that you should have about mirrors and reflection. That's all you learned in O levels. But based on this, they can ask a lot of questions. Okay. Clear? Based on that, they can ask a lot of questions. So we'll try a few questions and I'm going to soon quickly from reflection to refraction. Why? From refraction only the actual syllabus starts, okay? Clear? From refraction only the actual syllabus starts. So I'm going to quickly move to the next topic. But let's do a few questions. You have exercises towards the end of the book, okay? Here you have exercises towards the end of the book. So towards the end of the book, go to exercise 1. Try to do questions in this order. Go to exercise 1. Go to exercise 1. Do questions in this order. 3, 2, 4, and 1. Do questions in this order quickly. You can download the tute from the drive link. Okay. Provide the drive link again. You can download the tute from the drive link. Okay. Tutes are available on the drive link. If you can't find the tute, put a message. Okay. If you can't find the tute, put a message. Put the message to everyone. Okay. And in the live too. Okay. Download the tute from the drive link provided in the chat. There's a drive link provided in the chat. If you can't find a tute, put a message. And at the same time, you have to get the tutes delivered, and I'll provide tute delivery information towards the middle of the class. But I mean, last week we delivered almost all the tutes requested until now. Okay, but again, we'll try to send things so you know how to request for the tute. Okay, you know how to request for the tute, and I'll anyways join the group. We'll provide information on joining the group and all. Or just give a call to our number, our hotline, then solve whatever the issues you have if you are not in the group or anything like that. And definitely try to get your tutes delivered within this week. So we'll provide tute delivery information in the chat and in the group. Okay. Try to get your tutes as soon as possible. Okay. When you send a message, like within 5 days, we'll definitely send the tute. Okay. For anything else, just contact our number 070-154-6825. Go through these questions 3, 2, 4, and 1. Anyone who didn't get the tute? Anyone? Malik. quickly try to go through the questions. I'm not gonna give waste a lot of time on this, okay? I'm not gonna waste a lot of time on reflection because it's not meant to be explained in the syllabus. But we have to see the extent of questions that we are gonna get from reflection, that's why. Mali, provide the tube delivery number 2. Question 3. An object is placed between two parallel plane mirrors. Object is placed in between two parallel plane mirrors. There are two parallel plane mirrors. This is not a difficult question, okay? This is not a main question. Facing each other 20 centimeters apart. 20 centimeters apart. Okay. 8 centimeter from one mirror. It's a 8 centimeter from one mirror. So definitely it's going to be 12 centimeters from the other mirror. So where the first images are formed, so you know, right? The answer is very straightforward. The first image is formed here. Okay. At a distance of 8 centimeters. At a distance of 8 centimeters. And here the first image is then placed somewhere like this at a distance of 12 centimeters. Okay. At a distance of 12 centimeters. Clear? So now, this is not a very difficult question actually. If I ask you the next two images, where does the next two images form? the location of the next two images, I mean, you know this, right? I mean, if there are two mirrors like this, it's going to repetitively create a series of, okay? They are going to repetitively create a series of dots, right? You understand that? Clear? If you place an object like this and place two mirrors like this, it's going to keep creating images again and again, right? Right? Why? This is the image formed by this mirror, but that becomes an object to this guy and will create an image, right? Clear? This is the image created by this mirror, but that will be, it will become an object to this guy, then will form an image. This will keep happening, right? This will keep happening like for like 1,000 images, okay? It's gonna keep happening until the energy fades away, okay? Energy fades away. That means the next two images, so this becomes an object to this guy. This becomes an object to this guy. So what is the distance? What is the distance there? 12 and 8, 20, 28, okay? 28, clear? So from this mirror to distance to this object is 28. Then the image will be formed at a similar distance of 28, okay? Clear? Image will be formed at a similar distance of 28, clear? So this is going to be the next image. Like that, it's going to keep happening, okay? Like that, it's going to keep happening, clear? Okay, I mean, if I ask you, okay, you understand this? You understand this? So, like that, I mean, so this is the next first image, clear? Clear? So, now, I mean, if I ask you to, I mean, this is not necessary actually, but I mean, I'm just gonna show how things happen. If I ask you to show the ray diagram of this image, what is that? If I ask you to draw the ray diagram for this image from beginning, this is the actual object. From beginning, I need you to draw the ray diagram of this image. Can you draw that? Quickly try to draw that. If possible, try to draw that. Did you understand that the image is going to keep happening? Clear? Again and again? Okay? That is common sense, okay? If you are not understanding that, I mean, I don't know what to do. So, it's common sense. You know that things gonna keep repeating, right? But try to draw the ray diagram from the object to that image. From the object to this blue color image, try to draw the ray diagram. Quickly. I mean, I'm going to repeat this every week, but I mean, because it's necessary. So, I mean, just like you have like 1 year and like 2 months for the exam. So, start planning things for A levels, okay? Now start planning things for A levels, okay? That means, yes, physics is going well. I mean, at least from the covering syllabus point of view, things are going well. no big issue there. But I mean, if your chemistry or bio or maths, if it's not going at the right speed, if it's not going to be covered like at least 5 months before the exam, start working on it. Okay? Start a small group with few of your friends. Okay? I mean, talk to another, who do individual classes or someone from a university. Then try to finish the final few lessons. Okay? Or just buy some recordings and watch the final lessons. Like that, start taking actions. Okay? Why? You just go now and try to talk with a person from the 26th batch who haven't covered the syllabus yet. I mean, they are depressed, okay? They are not in a mental condition that they can write an exam, okay? It's not about the syllabus at the end of the day. It's not about covering the syllabus. It's the depression they go through. Why? When there is no enough time to cover the syllabus, nowadays, chemistry revision classes happen 3 days per week. Physics revision classes happen 3 days per week. Combined revision classes happen 3 days a week. So it's altogether 9 classes per week for a student who haven't finished the syllabus. Just to finish the syllabus. And on top of that, there's a lot of content. That's why. On top of that, there are 3 paper classes for everyone. So altogether, there are 12 classes per week. And at the same time, they have the exam within 2 months. So just think about their mental condition. Okay? They are not in a very good mental condition to write an exam at the moment. Okay? None of these problems happen if you finish the syllabus 5 months before the exam for all 3 subjects, right? You live peacefully the last 5 months, right? Clear? So start taking actions now. Just because you all of a sudden remember, okay, now it's 5 months on for the exam, now I have to finish things, nothing's going to happen. There's not enough time then. So now think that your exam is close, okay? Now start thinking that your exam is close. Okay, your A-level exam is really close. So discuss with your teachers. Ask them, when are you actually going to finish the syllabus? When are you going to start the paper classes? How things would go in the future? Okay. Then based on that, talk with them. Okay. If the person tells, okay, I will finish the syllabus 2 months before the exam, talk with the person, okay, I need to finish the syllabus 5 months before the exam. So are there recordings that I can buy from you? Just directly ask from the teacher, okay? Are there recordings that I can get from you? Just get them. Start watching one by one. So start planning things. Start finishing things, okay? Clear? You start planning now, then you would peacefully finish things 5 months before the exam. Otherwise, it's not going to happen, right? Then you have to go through the same depression, like 10 classes per week when it is 2 months for the exam. I don't know how students are going to handle that, okay? Clear? It's too much. Especially this problem is there in single medium, okay? The major issue in the single medium, okay? Clear? Too much classes for students, okay? So start planning now, okay? Start planning now, okay? When you start planning like 5 months after, not enough time, okay? Clear? So start taking decisions and start planning now. Assume or think that your exam is really close, okay? Clear? So moving forward. So how do we draw the diagram for this guy? How do we draw the diagram for that guy? Pay attention. I'm not sure whether I have enough space for this. Pay attention. It's reflection loss. That means this is the object. This is the object. This ray goes like this. Another ray goes like this. Clear? This ray reflects back like this. This is going to reflect back like this. Clear? So the result of these two reflections create the image here. Clear? That is this image. The image formed at a distance of 8 centimeters. Image formed at a distance of 8 centimeters. Clear? Now, this reflected ray and this reflected ray will move like this. This reflected ray and this reflected ray will move like this. Clear? So for this mirror, it looks like these rays are coming from this point, right? Clear? For this mirror, it looks like these rays are coming from this point. Clear? So it's gonna reflect back like this, and again reflect back like this with an angle, similar angle. Clear? It's gonna reflect back like that. Clear? Clear? So now these two rays, clear? Clear? So now if you have your eyes somewhere like this, if you receive these two rays, it's gonna look like it's coming from here, right? So that is the ray diagram. That is the ray diagram belongs to this point, okay? Belongs to this guy. Clear? Got the idea? For this mirror, it looks like the object is this. Object is this. Clear? Object is this, coming from a distance of 28 centimeters. Clear? For this mirror, it looks like the object is this, right? Coming from a distance of 28 centimeters. Clear? So in this side also, it's going to be 28 again, okay? Like this, you should be able to handle ray diagrams. Why? Nobody have to teach them, right? Nobody have to teach these things because it's a reflection law, okay? Reflection law you learned in all levels, okay? So nothing complex. Clear? Okay? So these, like this, they can ask whatever the questions they need, okay? But I mean, there's no any theorems on that, okay? It's just the same theorem used in different ways, okay? Clear? Let's move to the second question. Second question. I'll show the whole diagram. Question 2. A child 160 centimeters tall stands in front of a plane mirror. His eyes are located 10 centimeters from the head below. Calculate the minimum height of the plane mirror must be for the child to see his full reflection. So this is a kind of popular question. Pay attention. Now, this is the person, okay? Height is 160 centimeters. Height is 160 centimeters. Clear? The height is 160 centimeters. Now, I mean, the eyes are here, somewhere like this. Clear? 10 centimeters from the head. 10 centimeters from the head. So what is the requirement for this person to see his whole body? Whatever the rays moving from this point should enter the eye. Whatever the rays starting from this point should enter the eye, right? That is the requirement, right? For this person to see his whole body, Whatever the rays starting from this point should enter the eye. Whatever the rays starting from this point should enter the eye, right? So for that to happen, from wherever you can find the mirror, it's going to be like this. If it falls with an angle theta, it's going to be the same angle theta here, right? Reflection loss. Clear? So you have to have the mirror here. Clear? And at the same time, whatever the rays moving like this should return like this again following reflection loss, okay? Should return again following reflection loss like this, then this. Clear? Clear? Okay? Whatever the rays moving like this should return to the eyes following reflection loss. Clear? So in that case also, if this angle is alpha, this should be alpha because it should follow reflection loss, okay? So the mirror should be here also. So this should be the length of the mirror, right? This should be the length of the mirror, clear? This is the length of the mirror. So now you should understand it is half of the person's height, right? It is half of the person's height. Why? See, these triangles, the behavior, see? Okay, see? Now I mean, if this is, can we zoom here? If this is x, if this is x, this is x. If this is x, this is x. Okay? If this is y, this is y. Clear? If this is x, this is x. If this is y, this is y. Okay? Clear? This is x, then this is, if this is x, this is x, then this is y, then this is y. Clear? Now as you see, what is the height of the person? X plus y, right? So the height of the person is 160 centimeters equals 2x plus 2y, which means x plus y would be 80 centimeters, right? X plus y would be 80 centimeters. Now see from here, height of the mirror is x plus y, right? See, from here to here, then from here to here. This part is x, this part is y. So the height of the mirror is x plus y. Clear? So this is the height of the mirror, which is 80 centimeters. Clear? Got the idea? Clear? Just reflection loss. That's why again, nothing new, okay? Nothing new. No new concepts used. Just reflection loss. But they can ask whatever the questions they need to ask, okay? Clear? Now, based on that, go to fourth question. Using the concept, go to fourth question. I'll provide the tut again. Put a message if you can't find the tut. Tuts are available in the chat. Okay. So this one. So the eye of the person is exactly at the middle of the room. Okay. That's what they tell, right? A man stands in room so that his eyes are in the center of the room. Okay. It's at the absolute center of the room. Pay attention. The eyes of the person is at the center of the room. The distance to the ceiling of the room is h. So this height is h. So this is h over 2, this is h over 2, this is L over 2, this is L over 2. Okay. A plane mirror is mounted on the wall in front of the man. Calculate the minimum length of the mirror must be in order to see the entire reflection of the wall behind the man through this mirror. So again, same reflection laws, right? Just draw the ray diagrams. So you need to see the whole wall. So whatever the ray starting from this point should follow the reflection laws and go until the eye, okay? So if this is theta, this is theta. Clear? Clear? Then whatever the rays starting from the top should happen the same with them. Clear? From symmetry, if this is theta, this is also theta. Clear? Everything should follow the reflection laws, right? Whatever the ray starting here should enter here. Whatever the ray starting here should enter here, right? They should always follow the reflection laws. So now it's all about applying tan theta properly, right? That means, and you should see this side and this side is also entirely symmetric, right? So doing the question for this side would be sufficient. See, this side and this side are similar, right? So in this case, if this height is x, if this height is y, okay, if this height is y, I can apply tan theta. How? Tan theta for this triangle, tan theta for this triangle. You should see it is 1 and 3, but we have to write steps, okay? That's why I'm doing this, okay? Clear? Otherwise you should see the ratio, okay? Clear? So, but I would write the proper steps. So tan theta equals here x over L over 2, right? Here tan theta is x over L over 2, clear? Tan theta is x over L over 2. And at the same time, tan theta here is y over L, okay? Y over L. Is it clear? Is it clear? Tan theta here is x over L over 2. Tan theta here is y over L. Clear? Tan theta is x over L over 2. Tan theta here y over L. So you know the answer here. So you have a 2x over L equals y over L. L cancels out. Y equals 2x. Y equals 2x. Here you get y equals what? 2x. Clear? Y equals 2x. So now you have what? This is x, this is 2x. So this part is 2x plus x, it is 3x. Clear? I mean, the mirror should start here. For me to see everything, the mirror should start here and the mirror should end here, right? Clear? Mirror should start here and end here. Clear? Why? It should receive this ray, it should be able to reflect this ray, it should be able to reflect this ray, okay? So the mirror should be able to reflect them, okay? Mirror should be able to reflect them, clear? Okay, so this is the mirror we are talking about. So in that case, height of the mirror would be, here this part is x, see? If this is x, this is going to be x, clear? And the other part is similar, right? This is x, this is 2x, so altogether this is 2x plus x, 3x, and this part is again x. This part is again x, clear? Okay, this part is again x, okay? So we can tell here 6 into x is the height of the wall. 6 into x. 6 into x is the height of the wall. And what is the height of the mirror? Length of the mirror? Length of the mirror is 2x. Length of the mirror is 2x. So from this one, 2x equals h over 3, right? 2x equals h over 3. Clear? So 2x equals h over 3. Okay. 2x equals h over 3. Let's go to the first question now. Let's move to the first question now. Vale. Anyone who can't find the tute? Anyone? Okay, we'll send you the tute. We'll provide the tute in the group too. We'll provide the tute in the group now. We'll provide the tut in the group. I mean, you have to be careful for the question one if you are using like relative motion or anything like that. Be careful, okay? Reflection laws, I mean, you have to be really careful when applying relative motion. Question one. Mali, did you provide the tut in the group? Did you get the tut? The students who asked for the tut, it's available in the group now. If not, put your like WhatsApp number in the chat. We'll send you the tut. Mali, check that. Okay, nice. Exercise 1. Here the exercises are towards the end of the book, okay? Exercises are towards the end of the book. Question 1. Pay attention, everyone. An object moves at a speed of 5 meters per second. There's an object moving 5 meters per second. There's an object moving 5 meters per second. Okay. And at the same time, there's a mirror. And the speed of the mirror is 1 meters per second. Speed of the mirror is 1 meters per second. Okay. Speed of the mirror is 1 meters per second. I mean, for me, the simplest solution would be to try to find what happens per second, okay? I mean, I'm not going to go into relative motion, okay? It's possible, but you have to be really careful. But I mean, for me, the easiest solution looks like just see what happens after a second. After a second, what is the position of the object? After a second, what is the position of the image? Then you can find the velocity of the image, right? So doing the question for 1 second seems to be the easiest solution. That means assume that at the moment this length is L. Assume that at the moment this length is L. If this is L, after 1 second, what happens? After 1 second, this object moves 5 meters, right? Why? Its velocity is 5 meters per second. Clear? After 1 second, this mirror moves 1 meter, right? Why? Its velocity is 1. Its velocity is 1, so after 1 second, it's going to move 1 meter. So now, this is the new object. Now, this is the new object. The new location of the object. New location of the object. This is the new location of the mirror. So from the previous one, initially, object was here. Pay attention. Initially, object was here. Mirror was here. Distance between the object and the mirror is L. So initially, the image will be formed. Image will be formed at a distance of L. Clear? Image will be formed at a distance of L. Clear? Image will be formed at a distance of L. Clear? Now, in the second scenario, this is the object. Clear? This is the object. So if this is L, this is going to be L minus 5. This is going to be L minus 5. And when this is L minus 5, this is 1, right? This is L minus 5 and this is 1. So in the new scenario, distance from the object to the mirror, in the new scenario, distance from the object to the mirror is this, right? Clear? What is that? L minus 5 plus 1. L minus 5 plus 1, which means L minus 4. Clear? Clear? Then, if the distance between the mirror and the object is L minus 4, image will be formed at a distance of L minus 4, right? So, the image will be formed at a distance of L minus 4. Clear? So, this is the new image. This is the new image. So, this is the previous image. This is the new image. So, now you know the distance traveled by the image in 1 second. Here to here. Now you know distance traveled by the image in 1 second. It went from here to here. Clear? That is going to be the velocity. Distance per second. So let's find this distance. How can we find this distance? How can we find this distance? That's enough information. This is L. This is 1. So this distance would be L minus 1. This is L minus 1. This is L minus 4. This is L minus 1. This is L minus 4. Then this should be 3, right? L minus 4 plus 3 becomes L minus 1, right? So the image moved 3 meters in 1 second. So the velocity of the image is 3 meters per second. Velocity of the image is 3 meters per second. Clear? Okay. Velocity of the image is 3 meters per second. Write this down. So if you use relative motion, you have to be really careful. Sometimes things should be doubled. Okay. Sometimes things should be doubled. So using relative motion is not a very good thing in this scenario unless you have a very good clarity about what you are doing. Okay. Otherwise, just do things for 1 second, okay? 1 second before and 1 second after. Just compare them, okay? This seems like the easiest solution. Anyone need me to explain this again? Anyone? Quickly? Anyone? No, right? Yes? Okay. I'll quickly go through this again. Okay. See what happens. Okay. Pay attention now. See what happens here. I'm not going to do anything complex. Just show the whole thing. I'm not going to do anything complex. I'm going to do I'm going to try to find what happens 1 second before and 1 second after, which will give me the distance traveled by the image in 1 second, which means the velocity of the image, right? That is the whole meaning, right? So what we are going to do is, here you have the object. Here you have the object initially, and at a distance of L, you have mirror. So the distance from the mirror to the object is L. So the image will be formed at a distance of L. Now after 1 second, the object moves by 5, which makes this L minus 5. But the mirror moves by 1, because its velocity is 1 meters per second. So now the new object and the new mirror, distance L minus 4. Why? L minus 5 plus 1, which becomes L minus 4. So now the object is at a distance of L minus 4 from the mirror. So the image will be formed at a distance of L minus 4. Clear? Image will be formed at a distance of L minus 4. Why? Since the object is placed at a distance of L minus 4, image will be formed at a distance of L minus 4. Clear? If that is L minus 4, initially the image was here, now the image is here. This length is L. Now this is 1, mirror moved by 1. So this is L minus 1. And from the new mirror, distance to the previous image is L minus 1. From the new mirror, distance to the current image is L minus 4. This gap is the distance traveled by the image. The image went from L minus 1 to L minus 4, which creates a gap of 3. So within a second, the image moved by 3 meters, okay? Within a second, image moved by 3 meters, which makes the velocity of the image 3 meters per second. Now you should see, in this case, now you should see, like, it's the same laws, okay? It's the same laws as usual, nothing new, no new concepts used. Same reflection law you know, but they can ask whatever the mechanics they can put into the question, okay? They can put any mechanics into the question, okay? Clear? They can put any mechanics into the question and ask, okay? Clear? So they can make it complex whatever the way they need, okay? So that's the issue there, because they assume that you know things from all levels, okay? Let's move forward. No point of staying in reflection for a long time. Why? It's not in the syllabus. It's from all level. I just showed you how things can be or should be used, okay? So let's move forward to the syllabus, actual syllabus. That means we have to start with refraction. We have to start with refraction. So you guys have a rugger team for June 15th? Really? I think, yeah, 28 people would also have at least one rugger team, so it would be against one. So you're going to actually, I'm not going to guarantee security or any ambulance, okay? You would have my vehicle, you can go to the hospital by my vehicle, that's all. Or by Uber. Okay? Nothing happens under my consent, okay? If you need, we can have some people from our staff to play rugger with you. We have few large, we can go with Pune Jainita, like we have a few people addicted to the gym, so would be a good competition. And at the end of the day, you don't know what is staff and what is not staff. So we would be, bringing anyone we need and call them staff. Same goes with cricket. We're not going to do that, but we can. Okay. Let's move forward. Refraction. Refraction. Okay. The next topic. Refraction. Okay. So I hope you know, okay, it's June 15th, next Monday, okay? June 15th, next Monday, we have the event, like forever postponed cricket match and the Aurudutsavi. Okay. So it's like 2 months after Aurud, right? Okay. So it's the ground is in at Kotte, okay, so not very far away, it's close by. From 8 a.m. to 8 p.m. So just try to join, okay? You guys have nothing useful to do these days. So, you guys actually have, 28 people are the useless people these days. They have nothing useful to do these days. You guys actually have, but it's just one day, so I think you can manage. Okay, there's no point of going to school every day, right? So, try to be there. Okay, there would be a lot of games, DJ, food and everything. So try to be there on June 15th, okay? Monday, next Monday. At ground court day, so the location will be available in the group. So let's move forward. Pay attention. The main topic, refraction. 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 So what is refraction? Ray reaching a boundary. Ray reaching a boundary. Now pay attention. Ray reaching a boundary. After hitting that boundary, it's gonna move in a, we don't care whether it's a different path or not. Refraction means it falls to the other side, okay? Refraction means it falls to the other side of the boundary, okay? Clear? It's gonna move from one side to the other side of the boundary, clear? Usually there's, it's not, nothing is a perfect refraction or a perfect reflection, okay? Nothing is a perfect refraction or a perfect reflection. So, like, it's about the number of photons, okay? You would have a very good absolute clarity when we do matter and radiation. There would be a seminar for matter and radiation too, okay? So, when we do matter and radiation, you would have an absolute clarity, but last week when we were doing laser, I explained you it a bit, right? Optics or any electromagnetic wave is not something like something continuous. It's made out of energy packets called photons, right? Okay, and that you know, right? It's a theory of Einstein's, okay? Energy is made out of packets called photons. Okay, no one knows this at the moment. You would have an absolute clarity in matter and radiation lesson, okay? Pay attention. So these photons, this reflection and refraction means this is basically a barrier. Based on the size and other properties of this barrier, some number of photons fall to this side, some number of photons fall to the same side. That is reflection and refraction, okay? Okay? Clear? Some number of photons will move to this side, some number of photons will move to the other side. Same. So it's that is reflection and refraction. So based on that, there are 50% reflection, 50% refraction systems, 99% reflection, 1% refraction systems. Okay, 99% refraction, 1% reflection systems, entirely based on the material. Okay, clear? So this if it is a good refraction, okay, if it is a good refraction, okay, what happens at that time we call a partial reflection, okay? If it is a good refraction, okay, if it is a good refraction, it's not like it's 100% refraction, okay? Even when a refraction happens, at least a small amount of energy will reflect, okay? We call that a partial reflection, okay? So at the same time, even when a reflection happens, at least a small amount of energy, okay? At least a small amount of energy will refract. We call that partial refraction, okay? Clear? So it's not like reflection and there are reflection and perfect refraction. Okay, it's just the percentage of what's happening. Clear? Okay. So anyways, talking about this refraction, hope you can remember from O level what decides this behavior is the refractive index, right? The refractive index, can you remember the term from O levels? Okay. So it's going to be the refractive index that decides what happens in a refraction. Okay. So in that case, like take this barrier. Now, I mean, there are again two refraction laws. Okay. Pay attention. There are two refraction laws. They are, if this is the refracting boundary, the incident ray, the perpendicular line I draw to the incident point, and the refracted ray lies in the same plane. Okay. Again, it's two-dimensional. Okay. This and this lies in the same plane. Clear? This and this lies in the same plane. Clear? Then we call this the incident angle I. We call this the incident angle. This we call the refracted angle. The incident angle and the refracted angle, I and R. Okay. This is I and this is R. This I and R are connected by Snell law, right? I and R are connected by Snell law. Here we need the term, the refractive index. Okay. Here we have to use the term refractive index. Refractive index is an optical property, mainly an optical property of a medium. Okay. Refractive index is an optical property of a medium. That is, what is the velocity of optical rays in a vacuum? C. 3 into 10 to the power 8. Clear? Electromagnetic waves don't move with the same velocity in every medium. Okay, they have different velocities in different medium. Clear? So the velocity in this medium, if it is v, clear? Velocity in this medium is v. Okay. The refractive index we can write, okay, using c over v. Refractive index we can write using c over v. Clear? That means refractive index of this medium, it's just an optical property representing its velocity. Refractive index of this medium is velocity of light in a vacuum divided by the velocity of that ray inside a certain medium. Clear? C over V. Okay. So if the name of this medium is A, we call this the refractive index of A. NA. Clear? NA. Now, I mean, this is absolute refractive index. There are relative refractive indices too. Okay. We can define relative refractive indices too. Clear? That means the notation is we can write n refractive index n 1, 2, or the same thing you can write as refractive index n 2, 1. The same thing you can write as n 2, 1. All these notations are used for the same thing. That is refractive index of medium 1 relative to the refractive index of medium 2. Refractive index of medium 1 relative to the refractive index of medium 2. Which means, so this is slightly different from the Snell law you learnt in waves lesson. Okay. In the waves lesson, we just referred to the velocity. Here it's the same story like as in the waves lesson. But here we define and we use the term refractive index. Okay. Clear? So here N12 written like this, or N21 written like this, or N21 written like this, everything represents refractive index of medium 1 relative to the refractive index of medium 2. Okay. Clear? Which means N1 means C over V1, velocity in the medium 1. N2 is C over V2, velocity in the medium 2, which means V2 over V1, okay? Which means V2 over V1, clear? Okay, V2 over V1, clear? So that is the relative refractive index, okay, clear? That's the relative refractive index, okay, clear? So I mean, when it comes to Snell law, okay, in all levels we just write something like n equals sin I over sin I over sin r, okay? Without much of a clarity, we just write n equals sin I over sin r. We are not going to do that here, clear? We write n equals, just n equals sin I over sin r, okay? So, and again, I mean, this session is mainly for 27 batch, okay? For 28, another optics session would happen, okay? Another optics session would happen because I mean the speed and everything differs, okay? Speed and everything, the concepts I use differs a bit when I'm explaining for 27 batch and 28 batch, because 27 batch have done op waves lesson, okay? But still, this is going to be manageable if you want. But I mean, for 28 batch, I'm going to start a separate way optics lesson, okay? So moving forward, pay attention. N equals sin I over sin r, okay? N equals sin I over sin r. The improved version is, okay? The improved version for, I mean, for A-level syllabus would be N, there's not a huge difference. N, maybe we can call 2, 1 equals sin I over sin r. That's the only difference, okay? We properly define the relative refractive index here, okay? We properly define relative refractive index here, okay? N2 1 equals sin I over sin r. That means if I draw things properly, okay? If I draw things properly, this is the first medium where incident happens. This is the second medium where refraction happens. This is I. This is R. Pay attention. This is I and this is R. Okay. This is I and this is R. So if this is the first medium, the refractive index of that medium is N1. If this is the second medium, refractive index of that medium would be N2. So we properly define that like sin I over sin R equals N 2 1. N2 1. N2 1 means refractive index of the second medium relative to the refractive index of the first medium, okay? N2 1 means refractive index of the second medium relative to the refractive index of the first medium, which means N2 over N1, clear? Which means N2 over N1, clear? It's going to be N2 over N1. See, refractive index of the second medium relative to the refractive index of the first medium. Clear? Clear? So, I mean, how I usually remember and write Snell law is not like this. It's easy to remember. We cross multiply. We cross multiply. Then we get N1 sin I. We get N1 here, sin R here. Then we get N1 sin I equals N2 sin R. Okay. We get N1 sin I equals N2 sin R. That means refractive index of this medium into sine angle of that medium equals refractive index of this medium into sine angle of this medium. That would be the best way to remember things. Okay, clear? Okay, because I mean in all of us they just mentioned as n. Now it's not just n, we have to properly define. Okay, we have to properly define what is this refractive index, what are the media we are considering, okay, the relative connection between them. Okay, so the best way to remember this and write this would be, you just write the refractive index of this medium into sine I. That means the angle of that medium. Then refractive index of the other medium into angle of that medium. Clear? So n1 sine I equals n2 sine R would be the best way to write this. Clear? Okay. So this is refractive. This is Snell law. Okay. So some refractive indices are given in the tute. Okay. Then there are, these things happen, we'll got to know in waves lesson 2. So the proof for anything is not needed in this lesson. You just have to apply Snell law, but hope you can remember from the waves lesson, we proved the Snell law, okay? That proof is not necessary for the optics lesson. That's why I said without waves lesson, you can learn optics lesson. Clear? But you should remember that we proved Snell law in the waves lesson using wave fronts and all, right? Clear? So anyways, so there's a denser medium and a rarer medium. There's always a denser medium and a rarer medium. Clear? Then if a ray goes from a rarer medium to denser medium, it's gonna bend towards the line, right? It's gonna bend towards the line, but you don't have to remember these things anymore. Why? Now you know the Snell law and you can see what happens, okay? Now you know the Snell law and you can see what happens, okay? Now it's gonna bend towards the line, okay? Clear? It's gonna bend towards the line. Then in the next one, okay, if a ray moves like this from a denser medium to rarer medium, if a ray moves from a denser medium to rarer medium, it's gonna bend away from the perpendicular line, okay? Clear? It's gonna bend away from the perpendicular line, okay? From rarer to denser, it's gonna move towards the perpendicular line. From denser to rarer, it's gonna move away from the perpendicular line, okay? Clear? So these things are not actually necessary, just mention, because now we have the Snell law, so we don't have to think about what is happening. You can apply the law and see what is actually happening, okay? So quickly go to exercise 2. Exercises are towards the end of the book. Go to exercise 2. Question 1. Part 1 and 2. Question 2. A and B. Question 3. Try them. And usually a refractive index of a vacuum is 1, right? Why? In a vacuum it's going to be C over C. Refractive index of a vacuum is 1. Why? It's going to be C over C. But since air is almost similar to a vacuum, we consider refractive index of air as 1, okay, clear? We even consider the refractive index of air as 1, clear? So you can use that if needed, okay? Let's quickly go through the questions. Which part do you need me to explain? Okay, so I mean to explain the notations again, N2 1 means refractive index of the second medium relative to the refractive index of the first medium, okay? Same thing you can write by taking 1 here or taking 1 here, okay? Clear? That means you can write it as N, just keep 2 here and 1 here. Or just keep 2 here and 1 here. Relative to 1, relative to 1, relative to 1. So it's refractive index of the second medium relative to the first medium, okay? And even in when a refraction happens, what happens is, if this is I, and if this is R, if this is N1 and if this is N2, if this is N1 and if this is N2, the Snell law means sine I over sine R. Equals the refractive index of second medium relative to the refractive index of the first medium, which can be written as N2 over N1. So the easiest solution would be cross multiply. Then you write N1 sin I. You can write N1 sin I equals N2 sin R. N1 sin I equals N2 sin R, you can write. Clear? Okay. So the easiest way to write things are this medium into this angle, this medium into this angle, okay? Clear? So the first one, not a big deal actually. Part 1, NOW means NW over NO, NW over NO. So NW is 4 over 3, NW is 4 over 3, NO is 5 over 4. So use all this, you get the answer. Second one, ONG, which means NG over NO, NG over NO, which means NG is 3 over 2, NO is 5 over 4. NG is 3 over 2, NO is 5 over 4. Then you have the answer, okay? So that's all for that question. Let's move to the second one. Second one, A, here you have 30 degrees, then you have 25, this is air, so the refractive index can be considered as 1, as I mentioned. Since it is air, refractive index can be mentioned as 1. So this is N2 we have to find. So just apply Snell law. N1 sin I, N1 sin I, pay attention, equals N2 sin R, equals N2 sin R. So N1 is 1, refractive index of air is 1. Here sin 30, here sin 30 equals, here we have to find N2, sin R is, pay attention, sin R is sin 25. Sin R is sin 25, clear? This into this. So we get N2 equals sin 30 over sin 25. Sin 30 over sin 25, okay? We get sin 30 over sin 25, clear? N2 is sin 30 over sin 25. Moving to the next one, B, you have 60 degrees, pay attention, you have 60 degrees, then they need you to find R. Refractive index in this medium is 1. Refractive index of this medium is 1.5. So we can write N1 sin I n1 sine I equals n2 sine r, n2 sine r. So n1 is 1, n1 is 1, sine I means sine 60. Sine I means sine 60. Then you have n2, which means 1.5. n2 means 1.5 sine r. Sine r. So now you can write sine r equals sine 60 means root 3 over 2. Sine 60 means root 3 over 2 over 1.5. Clear? 1.5, which is root 3 over 3, which means 1 over root 3. Okay? So we can write r as sine inverse 1 over root 3. Clear? We can write r as sine inverse 1 over root 3, but it's good if you can use the logbook and find the final answer, okay? In a paper, don't keep it like this. Find the final answer using the logbook, okay? So, I mean, no point of doing thousands of questions. It's the same thing, okay? n1 sine I equals n2 sine r, okay? No matter how many questions we do, it's going to be the same, okay? So, we are going to move quickly to the applications of this theorem. Then we have like a series of nice questions, okay? That is the thing. Applying Snell law is nothing. It's the same thing. So, we have to quickly move to the applications of this. Applications of Snell law and applications of refraction, we can ask some nice questions, okay? So let's move forward. Let's do question 3 quickly and move forward. Let's do question 3 and move forward. After doing applications, I'll return to this exercise again, okay? So root 3 over 3 means 1 over root 3, right? Because 3 means root 3 into root 3. Okay, this one. An object is, here, pay attention, find the angle of emergence and the total deviation of the ray AB when the light ray AB passes through the glass sphere and exits into air. So it's a good question, okay? Otherwise, there's no point of just doing this again and again. Just applying Snell law again and again. It's just n1 sine I equals n2 sine r. After that, you use the logbook, get the answer, okay? Clear? n1 sine I equals n2 sine r, then use the logbook and get the answer. In a scenario like this, we have to think a bit. So if this is 30, it will create a certain refracted angle R. They are not talking about this, they are talking about emergence, that means coming out of the sphere, moving out of the sphere. They are not talking about this, they are talking about moving out of the sphere, the ray that moves out of the sphere. So if this is R, this is going to be R. Why? This is the radius. So since this is also R, let's use the symbol L for the radius. This is L and this is L, right? It's a sphere. It's a sphere. So if this is L, this is going to be L. Clear? So if this is R, this is going to be R, right? If this is R, this is going to be R. So the same way, actually, so for the same way, this is also going to be 30, okay? Clear? The same way, this is going to be 30. Clear? Why? Same Snell law. 30 and R, then R and 30, right? I mean, let's do the question, but I mean, no point of like going through a lot. When this is 30, this is R. When this is R, this should be 30, right? Because the same refractive indices, clear? Same refractive indices, I have to compare, right? Clear? Same Snell law, I have to apply for this 30R and this R and this one. So it is again going to be 30. Okay, no need to go through a lot of stuff. Again, it is going to be 30 anyways, okay? Clear? Again, it's going to be 30. Clear? Now, this is air. So the angle of emergence, that I know it is 30. Okay? Angle of emergence, they have asked, it is going to be 30 anyways, okay? It is going to be 30. Then they are asking total deviation. This is a common thing that they usually ask. What is the total deviation? The angle the ray bends, okay? That means this is my initial ray. It is moving in this direction, okay? That ray, it is moving in this direction, like this. It's moving in this direction, clear? Now this is the emergence. It's moving in this direction, like this. It's moving in this direction, clear? So this is the total deviation I'm talking about, okay? The ray deviated by this angle, right? It was going in this direction, clear? Now it bends and moving in this direction, clear? So this is the deviation, okay? This is the deviation, the angle of deviation, okay? Clear? So how can we find that? Just let's take it as sum of two simple deviations. That means this whole deviation is made out of two paths, right? Whatever the deviation happens here and whatever the deviation happens here, right? The total deviation is made out of two paths. Whatever the deviation happens here and whatever the deviation happens here, clear? Okay. So let's use two simple deviations. This is 30. Then this is also 30. This is 30. So this is also 30. Clear? So the deviation happening here, the ray was moving like this. Now it bends until here. Clear? If this is 30, this is 30. So this deviation would be D1. That deviation D1 would be, if this is 30, this is R, D1 would be 30 minus R. 30 minus R. Clear? This is 30, this is R, so this deviation part would be 30 minus R. Now this ray is moving in this direction, see? Now after that first deviation, it's moving in this direction, clear? Later here, it bends by this value, D2. It bends by D2, clear? Later here, it bends by D2, clear? So there, if this is R, See, if that is R, this is going to be R, right? You had names for this stuff, okay? In O levels, if this is R, this is going to be R, right? Clear? Clear? So now D2 is what? See, this whole angle is 30. It was moving in this direction, bent by this value. So this is D2, deviation. D2 equals 30 minus R, right? D2 equals 30 minus R. Clear? So what is the full deviation? Full deviation is D1 plus D2. Full deviation is D1 plus D2. That means 30 minus R plus 30 minus R. That means 30 minus R into 2, which means 60 minus 2R. So I have to find R, right? I have to find R. For that, I have to apply Snell law here. This medium is 1. This is 1.5. This is 1.5. So 1 sine 30. 1 sine 30. If I apply Snell law, I get 1 sine 30. Sine 30 equals here 1.5 sine R equals 1.5 sine R. 1.5 sine R. So sine 30 is half. I take this 1.5 here equals sine R. So sine R is 1 over 3. Use the logbook to find R. Use the logbook to find R. So bring logbooks, okay? Bring logbooks every day. It's 19. This is from the calculator, so will be a bit different from the logbook. Why? Logbook is just an approximation, not actual values. So R is 19 degrees and 28 minutes roughly. So the answer would be 60 minus 2, R means this, 19, 28. Okay, 19, 28. So this is the deviation. This is the total deviation. Just mention if you didn't understand that, or else go to question 4. And some questions from exercise 3 you may be able to try. I'll give you the interval. Yeah, be here by... At what time do we finish the class? Optics since 7:30, right? Okay, I mean, be here by 6. And start doing these questions, but I won't do this stuff. I'll move to the next theory point, which is applications of refraction. Okay, if you didn't understand this, put a message, okay? Then I'll go through them again. And I'll provide the tube delivery information again, okay? I'll provide the tube delivery information again, so online students try to receive tubes as soon as possible. Put the tube delivery information in the Zoom chat also. Okay. Question 4. Question 4. Exercise 2, question 4. Exercise 2, question 4. A ray is refracted through several media of refractive indices. Trace the ray until it exits back into air. Find the angle of refraction of air and one interface, angle of refraction 2, 3 interface, angle of incidence of back to air. So this is the system. Falls with angle 60. Falls with angle 60. This is 60. Then this, let's take as I1. Let's take as maybe R1. Here, let's take this as R1. Then the same R1, pay attention, same R1 will be received here, right? Same R1 will be received here, clear? From the loss, same R1 will be received here. Based on this R1, the refractive index here is √3. Based on this R1, a certain R2 would happen. A certain R2 would happen, okay? Based on this refractive index, and this refractive index is 1.5, pay attention. This refractive index is 1.5, okay? Then if this is R2, this is going to be same R2. This is going to be the same R2. Based on that R2, this angle would happen. Let's take it as R3, okay? Let's take it as R3, okay? So this is the whole process, right? So I mean, in the questions, what they are asking is R1, R2, and R3, right? So quickly apply Snell law. This is 1, √3, 1.5, back to 1, right? Refractive indices are 1, √3, 1.5, and 1. So 1 sin 60. So we can write 1 sin 60, Snell law. For the first interface, 1 sin 60. 1 sin 60 equals √3 sin R1. √3 sin R1. So sin R1 equals, sin 60 means √3/2. Sin 60 means √3/2 divided by √3, which means half. Sin R1 is half, which means R1 is 30, right? R1 is 30, clear? R1 here is 30. Then after that, let's apply the Snell law here. Let's apply now the same R1 I receive here. Same R1 I receive here. So let's apply Snell law here. √3 sin R1. √3, pay attention, sin R1 equals √3 sin R1 equals 1.5 sin R2, right? √3 sin R1 equals 1.5 sin R2. 1.5 sin R2. √3 sin R1 equals 1.5 sin R2. So we get sin R2 equals here root 3, then sin R1. Sin R1 means sin 30. Sin R1 means sin 30 over 1.5. Over 1.5. So you would get root 3. Sin 30 means half over 1.5, which means root 3 over 3, which means root 3 over 3, which means 1 over root 3. It is 1 over root 3. Sin R1, sin R2 is 1 over root 3. Sin R2 is 1 over root 3. Clear? Hope I'm doing the calculations correctly. Sin 30 half, so half into 1.53. Root 3 over 3 means 1 over root 3. Clear? Okay. So what is R2? What is R2? I'll go to the calculator for now. $35. R2 is 35 and roughly 16. Then back to this point, it is the result of applying Snell law here. It is the result of applying Snell law here. Using that we get R2. Then same R2 we receive here, okay? Same R2 we receive here. So let's apply Snell law here. It's 1.5 and 1, so 1.5 sin R2, 1.5 sin R2, 1.5 sin R2 equals here 1 sin R3, 1 sin R3. 1.5 sin R2 equals 1 sin R3. So sin R3 equals 1.5 sin R2. See 1.5 sin R2. What is sin R2? This, right? 1.5 sin R2. Sin R2 means this. Clear? Sin R2 means this. So sin R2 I'll write like this. Root 3. Okay. So what is actually sin R3? We can write 1.5 as 3 over 2. We can write 1.5 as 3 over 2. Then you have 1 over root 3, which means you are going to get root 3 over 2. Which means R3 is 60 degrees, right? Sin R3 root 3 over 2 means R3 would be 60 degrees, okay? Clear? So it's enter with an angle of 60. It enter with an angle of 60, goes out with an angle of 60, okay? Clear? And that is just a fact, okay? That is just a fact. Just a fact means, if the boundaries are parallel, it will always have the same angle in the same medium. See, this medium is 1, this medium is 1. This medium is 1 and this medium is 1. So these two are equal. If the boundaries are parallel, it will always have the same angle. If the boundaries are parallel, it will always have the same angle in the same medium, okay? Clear? Write this down quickly. Let's move to the new theory point. just continuously applying refractive Snell law, okay? Continuously applying Snell law. Okay, so it's just applying Snell law from beginning. 1 sin 60 equals root 3 sin R1. Then root 3 sin R1 equals 1.5 sin R2. Then 1.5 sin R2 equals 1 sin R3. Okay, just continuously applying Snell law. Only the whole one. Okay. Quickly write this down. Quickly write this down. So applying 1 sin 60 equals root 3 R1. Root 3 R1 equals 1.5 sin R2. 1.5 sin R2 equals 1 sin R3. Continuously applying Snell law. Okay. And it's always the same angle because they are parallel. Pay attention. Because the boundaries are parallel. If this is R1, this is R1. If this is R2, this is R2. Okay. That happens because the boundaries are parallel. That's why I mentioned if the boundaries are parallel. That's why I said if the boundaries are parallel in the same medium, you would have the same angle. Okay. Only if the boundaries are parallel. Clear? Because then only R1, R1, R2, R2. This happens. Okay. So quickly finish writing this. Okay, pay attention. Pay attention. Now I mean applications of refraction. Okay. Applications of refraction. So the first thing you actually had in O levels, real depth and apparent depth relationship, right? Can you remember? The real depth, apparent depth relationship, it was there in O levels, okay, in the O levels book as I remember. Okay. That means, pay attention, as a result of refraction, things may be underwater or inside a glass or something like that, don't appear at the correct place, okay? Don't appear at the correct place, actually at the correct depth, okay? Why? What is the reason? If there's an object here, if this is maybe water, if this is air, if this is water and this is air, this ray will go in a straight line, okay? Why? Pay attention, this ray will go in a straight line because it falls with a 0 angle. It falls with a 0 degree angle, so it will go in a straight line. But the next one, this one, clear? We may have to apply Snell law, right? If this is I, there would be a certain R here. There would be a certain R here, clear? So now if you are looking from above, okay, if this is your eye, okay? Now I mean, these rays, these two rays would enter the eye, right? These two rays would enter the eye. So based on that, the brain will create the image where? The brain don't know the story. The rays went in this direction, then went. So the brain don't know this story on what actually happened. It's going to use these two lines to model the point. So it would appear to be here, right? In that case, it would stay here, right? So this is where you're going to see the image, okay? This is where you're going to see the image, clear? Okay. Just to make the proof easy, let's change this diagram a bit. So this is R. So this is where you would see the image, okay? This is where you would see the image, okay? Why? Based on these two lines, okay? Pay attention. Based on these two lines, they come from a point like this, right? They come from a point like this. So the perspective of this person, the object is here, okay? But the actual object is here, okay? So this is the real object. This is the apparent one, okay? This is the apparent one, clear? Okay? So I mean, if we try to create an equation for this, if this is I, this is I, right? If this is I, this is I. If this is R, this is R, right? You had names for these angles, okay? If this is I, this is I. This is parallel. So if this is R, this is R, okay? So we can write, let's take this medium as N1, this medium as N2. So let's apply Snell law to this point. N1 sin I, it is going to be N1 sin I equals N1 sin I equals N2 sin R, right? N1 sin I equals N2 sin R. N2 sin R. Okay? We are going to get N1 sin I equals N2 sin R. Clear? So in that case, I'm going to get something like this. Sin I over sin R equals N2 over N1. Sin I over sin R equals N2 over N1. Clear? Now, moving forward from this point, okay? Moving forward from this point, like it is sin I over sin R equals N2 over N1. Then, although I draw this diagram as a huge diagram with huge angles, if this is the I, these angles should be really small, right? I mean, when you look from above, okay, I is really small, clear? So as a result, whatever the rays entering the eye should actually have very small angles, right? Clear? I is really small here. So if this is the system I'm looking at, whatever the rays entering the eye, all have very small angles, right? Clear? Really small angles. So these I and R both are actually small, okay? Although I draw it like this in the diagram, I and R should be really small when we consider that they are entering the eye, right? Clear? So as a result, you know that for small angles, I radian equals sine I equals sine R, right? Sorry, sine I equals, I'll just write it in theta. Theta radians equals sine theta equals tan theta, right? We even check this with the logbook. Okay. Theta radian equals sine theta equals tan theta for very small angles, right? So considering these are small angles, I can write n2 over n1 equals sin I over sin R, which means tan I over tan R. I can write this as tan I over tan R, okay? Clear? Sin I over sin R, I can write as tan I over tan R, clear? So what is tan I? What is tan I? So let's think about this diagram. This is X. This is X. This is capital H, the real depth. This is capital H, the real depth of the real object. This is the apparent depth of the object. It's where it appears to be. Apparent depth of the object. Clear? So, tan I can write as X over capital H, right? See? Tan I can write as X over capital H. X over capital H. Tan R, I can write using X over simple H, right? Tan R, I can write using X over simple H. Clear? So we are going to get simple H over capital H equals N2 over N1, okay? We are going to get simple H over capital H equals N2 over N1. I'll just invert them. Then I would get capital H over simple H. Capital H over simple H equals N1 over N2. N1 over N2. Clear? Okay. And in many scenarios like this, N2 is usually AR, right? N2 is usually AR in many scenarios, right? Clear? N2, this medium where your eye is placed, is usually AR, right? So in not always, but in many scenarios, N2 would be 1. If N2 is 1, you would get capital H over simple H equals directly N1. Capital H over simple H equals N1. So this is what we would usually refer to. Real depth, apparent depth equation. Real depth over apparent depth equals the refractive index of water. If this is water, if N1 is water, if we are looking at something in water, we call real depth over apparent depth equals refractive index of water. Clear? If this is glass, real depth over apparent depth equals refractive index of glass. In many scenarios, this is what happens because usually eye is placed at air. Okay? But it's not the general equation, this is the general equation. Okay? This is the general equation that we have to know. Okay? Because I mean, it's not always the case. Okay? So it's good to remember the general equation. Easier way to remember the general equation, an easier way to remember the general equation would be See capital H. What is capital H? Real depth. Real depth is formed by rays in this medium, right? Real depth belongs to the rays in this medium. That means N1. So in front of real depth, we write N1. In front of real depth, we write N1. Then the apparent depth, simple H. It belongs to these rays, right? These rays together create this apparent depth, right? Clear? So whatever the rays in this medium create this apparent depth. So in front of apparent depth, simple H, we write N2. Clear? That would be a better way to remember. Clear? That would be a better way to remember, because it's not the case always that you are going to get this, okay? Sometimes the eye is placed in water and you are looking out. So things going to change again and again, okay? So just remember in this equation won't be sufficient. So good to remember this guy, okay? Clear? If you need, you can write this down, but it's included in your tute. But I mean, I think the proof isn't there. Yeah, so the proof isn't there because we need you to write that, okay? So there's a topic called images formed when light is refracted. There's a topic called images formed when light is refracted. Under that topic, write this proof, okay? Under that topic, write this proof. No need of this actually. For now, no need of this. Just write it as an additional point if you need. Okay, otherwise you may confuse and remember this, okay? So write the general equation, and if you need, with some extra mentioning, write this, okay? All right, when N2 equals 1, this happens. Write it separately, okay? So the tute delivery information is provided in the chat. So try to get your tutes as soon as possible. So maybe put a message to the tute delivery number today. Put a message to the tute delivery number today. So we'll, within like 4 days, we'll send you the tutes. So try to get your tooth delivered as soon as possible, because you may have to draw a few diagrams here and there, okay? Here, you may have to draw a few diagrams here and there. Okay, pay attention. So as you see, I mean, if the object is here, if the object is here, if you are looking from through water here, okay, if you are looking from here, what happens? This ray moves like this because it is the 0-degree one. It never bends. But the next one goes like this, then like this, right? Because this is the rarer medium, this is the denser medium, right? Air is the rarer medium, water is the denser medium. So in that case, these two rays will meet somewhere like this, okay? These two rays will meet somewhere like this, clear? They would meet somewhere like this, clear? Okay, so in this case, now see, things appear to be far away, not closer, things appear to be far away, okay, clear? That is the difference. Let's move to some questions, go to exercise 3. Exercise 3, question 1. So it's not actually seas, okay? That means the crow is here. The real depth, the real gap is 6 meters, and the fish is here, and the real gap is 8, okay? It's not properly mentioned in the question, that's why. It's not properly mentioned in the question. The crow is there, 6 meters above from the water surface. Fish is here, 8 meters below the water surface. Question 3. Question 4. Five. Let's try these questions. If possible, just finish all the questions, okay? Go through the questions as fast as possible. Quickly try to get answers, okay? I have always mentioned this. The reason for me to give questions before teaching how to handle the question, because otherwise you will never learn to try, okay? Otherwise you would never learn to try before, I mean, try without knowing a proper method, okay? So you have to try questions before me start teaching, okay? Clear? That's the only way out. Because at the end of the day, when you are doing A-levels, nobody tells the method. Nobody gives you at least a small support. You have to decide and move forward. I have mentioned this too. Don't even get a small support from your friend, okay? That means everyone have this habit. You just Okay, this should be the method. That kind of a conversation you do with the friend, right? Sometimes you do with the friend. Okay, I think this is the method. At least a conversation like that happens, right? Don't do that. Just start doing the question alone. Okay, why? Some students, I mean, they after doing that for a longer period of time, although they don't know that, they need that confirmation to move forward. Okay, so they grow that habit. They always need that confirmation from a friend or someone else. I think this is the method. What they're actually asking is, should I continue? Okay, you get so used to that confirmation, after a while you can't do questions without that. Okay, clear? And that happens heavily in A levels. Why? In the even in when you're writing our papers, you won't care. If it is wrong, it would be wrong. I mean, nothing's gonna happen when you get low marks in our paper, right? But in A levels, you can't move forward like that. Okay, you can't just ignore that. Okay, it's all okay. You're not gonna move like that. So then the problem happens. Why? You need that confirmation. You really need that confirmation, but at the A level, there's no one to give that confirmation, right? So then the real problem starts. There's always a doubt. So you can't move faster. This happens only in A levels. That's the problem. Okay, so the many students figure this out after doing first try. Okay, that is the problem. Clear? So don't get that confirmation. That's why I don't teach anything. Just give the exercise. Later start teaching. Now, if there's no clue, you only know the theory. Even without talking a word with your friend, start doing the question alone. Try to figure that out. Whatever the method you thought, continue with that until the final answer. Only when you have the final answer, maybe check that with your friend. It's okay. Clear? Okay, don't get used to that confirmation from your friend. Okay? Although it doesn't appear to be a huge thing, it's a huge thing. It's a huge problem. It's going to appear in the A levels. Then you won't be able to move forward without that confirmation anymore. Okay? That is going to be a huge problem. Clear? So just try alone. If you're not capable of getting the answer for the first one, move to the third one, then to the fourth one. Just keep moving, okay? If you need me to explain anything again, just mention, okay? Anyone, if you have questions, just raise your hand. And if you are done until 5, you can try question 6. Then question 12. Most of the questions you can actually try, okay? Not the second one actually. For that we need a practical. But usually the almost all other questions you can try. And online students, when you are like requesting the tute, request the heat tute also, okay? Because you have to follow the heat lesson too. So not only the optics, one, request for the heat tute too, okay? Question 1. A crow flies 6 meters above water. 6 meters above water. There's a crow here. And there's a fish swimming 8 meters below water. There's a fish 8 meters below water. What is the observed depth of the fish as seen by the crow? How high above the fish the crow flying as seen by the fish? The absolute refractive index of water 4/3. So this is air. So the refractive index is 1. This is water. Refractive index is 4/3. So now this is the fish. So the rays go like this. Then like this. Clear? So the actual depth is 8. Actual depth or the real depth is 8. Actual depth or the real depth is 8. The apparent depth where it appears to be, the apparent depth where it appears to be is simple h. Clear? The apparent depth where it appears to be is simple h. It is simple h. Now in front of 8, the real depth, you write the refractive index of that medium, right? Why? The real depth is formed by the rays in this medium. Real depth is formed by the rays in this medium. Clear? What is the medium? 4/3. 4/3. And the apparent depth, h, is formed by these rays, okay? Apparent depth, simple h, is formed by these rays, clear? Which are in this medium. Which are in this medium, clear? Apparent depth, simple h, is formed by these two guys. They are in this medium, which means 1. So simple h is 6 meters. 6 meters, clear? So the apparent depth of the fish is 6 meters, clear? Now, What is the apparent location of the crow? It looks like it's here. It looks like it's here. That's the actual location. That's the actual location. But the rays would go like this. Then like this. Clear? So they would meet somewhere like this. So the crow may appear to be somewhere like this. Clear? Clear? It would be seen at a point like this, simple H. Again, the same theorem. This actual location of the crow is formed by actual rays, okay? Actual location of the crow is formed by actual rays, right? Those actual rays are in the medium of refractive index 1. So this actual distance, which is 6, actual distance, which is 6, in front of 6 you have 1. Actual gap 6, in front of that you have 1. Then this is where it appears to be. Clear? This is where it appears to be, simple H. Due to which rays? These ones, right? These two rays meet here. So for this simple H, this refractive index matters, okay? So in front of simple H, you write 4/3. So H equals, in that case, let's take it as H2. Let's take it as H2. H2 is, when you solve this, you get 8 meters, right? 8 meters, clear? Okay. So the fish is actually at a depth of 6 meters, but appears to be at a depth of, the fish is actually at a depth of 8 meters, appears to be at a depth of 6 meters. The crow is actually above 6 meters above the water level, but appears to be at a height of 8 meters above the water level. Clear? Okay. Let's move to the next one. Okay. Got the idea? Clear? Go to the next one. Just keep finishing the questions. Not the second one. Others you can try. Other questions you can try. Don't use that real depth or apparent depth thing, okay? This is way better. Okay. The fish is at a depth of 6. But it appears to be somewhere like this. So you write 6/h equals 6 means it belongs to this medium, which means the refractive index of this medium. 4/, the actual depth is 8, right? Actual depth is 8. Actual depth of the fish is 8. and it appears to be at simple h. It appears to be at simple h. Actual depth belongs to this medium, these two rays. So you write refractive index of that medium in front of that. But this simple h belongs to this medium. So you write why this simple h is formulated by these two rays. So in front of that you write that medium. Clear? Like that. When you are looking from air, I mean after these many questions you are looking from air. In that case you can directly use real depth over apparent depth equals n. Okay? Like we mentioned before. Pay attention, pay attention. In many questions you would be looking from air, something inside a glass or water or something like that. In that case you can use this directly, okay? Real depth over apparent depth equal to refractive index, okay? But this is the actual general equation, clear? Okay? This only happens when this guy is 1, okay? Let's go to the next one. Question 3. It's not about real depth, apparent depth, a different question. Question 3. Pay attention now. So try to understand this, okay? I mean, these concepts, pay attention. These concepts sometimes I'm not repeating because I mean, there's a level of understanding we expect from a 27 batch student, okay? So sometimes in certain scenarios, I'm not going to repeat things because you may have to try and figure it out, okay? Clear? There's a level of understanding we expect from a 27 batch student. So you have to try to match that, okay? Clear? So if you're not understanding a question, it's okay, but you have to go home, go through the question again. The recording, the live recording is always anyways available for this class. It's available in the group. For all other classes, they are available in the website. Again, try to watch that part. Try to figure that out, okay? Clear? Repeating the same thing again and again for multiple times is not the best thing to do in certain scenarios. For 28 batch, yes, we can do that because they are just at the beginning. For 27 batch, we expect a certain level of understanding from them. If you are not going to match that, at least now, somehow try and match that, not at least now, then you are going to struggle at A-levels anyways, okay? So no point of understanding things now if you are going to struggle at A-levels, right? The ultimate at the end, at the ultimate exam, if you are going to struggle for sure, there's no point of doing this, okay? So in certain scenarios, I'm not going to repeat things. I'm going to maintain a certain speed because I mean, you have to grow that ability of understanding things faster according to all other 27 batch students, okay? Because you have to match that to get good results in A-levels, okay? Clear? Not understanding something now, the main goal is being able to perform in A-levels, okay? So try, if you are not understanding something, try to figure that out, okay? Try, okay? Let's move forward. A ray of light falls on a block of glass. A ray of light falls on a block of glass. It falls on a block of glass whose absolute refractive index is 1.62. So the refractive index of this glass is 1.62 and undergoes partial refraction and partial reflection. What is the angle of incidence if the reflected and refracted rays are perpendicular to each other? That means there's a barrier like this, okay? The ray falls like this with an angle I. Ray falls like this with an angle I. Okay? Then it's gonna reflect back. A certain amount of energy reflects back. That's what they are telling. It's a partial reflection. Even partial reflection follows reflection laws, okay? Even partial reflection follows reflection laws. So if this is I, this is going to be I, okay? If this is I, this is going to be I. Clear? Partial reflection follows reflection laws. Then after that, at the same time, the refraction is going to happen, okay? At the same time, the refraction would happen and it's going to follow Snell law as usual, okay? It's going to follow Snell law as usual and it will have an angle R, okay? And what they are telling is the angle between this reflected ray and refracted ray is 90 degrees, okay? Angle between the reflected ray and refracted ray is 90 degrees. So I can tell this I plus 90 plus R. This I plus 90 plus R equals 180, right? Okay. Here this I plus 90 plus R. Okay. I plus 90 plus R equals altogether 180. So I can write I equals 90 minus R. We can write I equals 90 minus R. Clear? Pay attention. We can write I equals 90 minus R. Clear? So if I is 90 minus R, now I can directly apply Snell law. Then I have the answer for tan I, right? Sorry, I can get the answer for tan R maybe. Okay, what they're asking, are they asking I, right? So if they need I, let's write this other way around. R equals 90 minus I. After solving this, I get R equals 90 minus I. So now apply Snell law here. What is this? This is air, I think, right? Yeah, they are not specifically mentioning that. So this should be air. So 1 sin I, Snell law, 1 sin I, 1 sin I, 1 sin I equals 1.62 sin R, right? 1 sin I equals 1.62 sin R. Okay. 1 sin I equals 1.62 sin R. Then I can write sin I equals 1.62 sin R. I can write sin, instead of R I can write 90 minus I, right? Instead of R I can write 90 minus I, and I know sin 90 minus I means cos I, right? Sin 90 minus I means cos I. Clear? So we are going to get sin I over cos I. We are going to get sin I over cos I. Sin I over cos I equals 1.62. Sin I over cos I means tan I, right? Sin I over cos I means tan I. Clear? Sin I over cos I means tan I. So tan I is 1.62, okay? Tan I is 1.62, clear? Okay. So that is the answer. Now you can find I, okay? Use the logbook. and find I. For now, I'll write it as tan inverse 1.62. Okay, tan inverse 1.62. Let's move to the next one. So first, let's move to question 5, then move to 4 later. After 5, go to question 6. After 5, go to question 6. Okay, here, this one. There is a 3 meter high wall near a pond. The reflection of the top of the wall reflected from the pond coincides with the image of the bottom of the pond refracted from the pond. How deep is the pond if the refractive index of water is 4/3? So this is not a very difficult question. I mean, the top of the wall, the height of the wall is 3 meters. So top of the wall will appear at a depth of 3 meters, right? Height of the wall is 3 meters here. So the top of the wall will appear as the image after reflection at a depth of 3 meters, right? So this is the bottom of the pond. So now if they coincide, that means this has become the apparent depth. This has become let's take the real depth as capital H. This has become the apparent depth, simple H. Okay. This has become the apparent depth, clear? Okay. Got the idea? So what is actually happening is, this is 1, this is 4/3. This is the height of the wall, and it's going to reflect here, okay? This height is 3, it's going to reflect here, clear? This is 3 and this is 3, okay? The actual depth of the pond is capital H. Actual depth of the pond is capital H. It is seen at a depth of 3 meters, okay? Actual depth of the pond is capital H. It is seen at a depth of 3 meters, clear? It's seen at a depth of 3 meters. So now you know the apparent depth, 3. You have to find the real depth, capital H. That means the actual depth of the pond, right? Clear? You know the refractive index, and this is air. As I mentioned, if you know the if one medium is air, if you are looking from air, you can directly write real depth over apparent depth equals refractive index, right? Because this is going to be anyways 1, okay? Clear? In that case, we can directly write real depth over apparent depth equals just n, okay? Equals just n, which means the refractive index, okay? Which means the refractive index, clear? Okay? So we can write n, real depth is, that's what I'm going to find, that I don't know. Apparent depth 3, apparent depth 3, here the apparent depth is 3, refractive index is 4 over 3. Refractive index is 4 over 3, clear? So 3 and 3 cancels out, capital H becomes 4. Capital H is 4. What is capital H? It's the actual depth of the pond, okay? Capital H is 4. It is the actual depth of the pond, clear? Let's move to the question 6. Yeah, sine 90 minus I equals cos I kind of stuff you have to know, okay? Here, basic trigonometric stuff we have done before. Sine 90 minus theta equals cos theta. Cos 90 minus theta equals sine theta. This kind of stuff you have to know. Sine 90 minus theta equals cos theta. Cos 90 minus theta equals sine theta. Question 6. Question 6. Okay, this one. Pay attention, this one. There's a rod submerged. There's a rod. Pay attention. Pay attention. There's a rod submerged. Its length is 40 centimeters. They need to know the submerged length. They need to know the submerged length. The question is not that clear. That's a fault from our side. The length of the rod is 40 centimeters. They need us to find the submerged length. They need us to find the submerged length. It appears to be is it appears as half of the rod is submerged. It appears as half of the rod is submerged. So if the actual submerged height is, I take as capital H, definitely the bottom of the rod will appear somewhere like this, right? Definitely the bottom of the rod will appear like this, right? At the apparent depth. Bottom of the rod will appear at the apparent depth, clear? So in that case, this is what I see. This is what I see. I won't see this part. I would see the apparent depth. I would only see the apparent depth. This part above I would see as it is, right? It's just above water. So that part I would see as it is. This is what I'm going to see. Clear? This is what I'm going to see. Got the idea? It's submerged by a height of h, but I'm going to see that height as simple h due to the real depth, apparent depth scenario. Okay? But the part above water I'm going to see as it is. But after seeing this, I think, okay, half of it submerged. After seeing this, after seeing what I see, I think, okay, only half of it is submerged. That means this H and this part is equal. That's why I think like that, right? That's why I think like that. Clear? This is simple H and this is simple H. These two parts are equal. The depth I see in water and the actual length I see above water are equal. The depth I see in water and the actual height above water are equal. That's why I think only half of it is submerged. That's not the actual case. More than half of it is submerged. Clear? So I mean, now we have few options, use real depth, apparent depth scenario and everything, then you can find the answer. Why? If this part is simple h, this part is simple h. Now I can use, for the rod, what is the real depth submerged? Capital H. For the rod, real depth submerged is capital H. Over apparent depth is simple h. Real depth over apparent depth, that means capital H over simple h, equals refractive index, right? Equals refractive index. So it is water, right? So refractive index of water is 4/3. This is a common value you can get from other questions, okay? When it is not given, always use this, okay? It is 4/3. Clear? So refractive index of water is usually 4/3. When not given, use that. If they give a different value, use that. So I can tell capital H, simple H again equals 3 capital H over 4. Clear? Pay attention. Simple H equals 3 capital H over 4. Now I mean you know the answer, right? Why? The actual length of the rod is 40 centimeters. Actual length of the rod is 40 centimeters. It is equal to simple H plus capital H, right? Actual length of the rod is equal to simple H plus capital H. Clear? So 40 equals simple H plus capital H. So it's going to be 40 equals, simple H is this, okay? This is simple H. 3 capital H over 4. 3 capital H over 4 plus capital H, which is 7 capital H over 4, which means 7 capital H over 4 equals 40. Then capital H, actual depth submerged is 160 over 7. 160 over 7 meters. Clear? 160 over 7 meters. So someone haven't covered the measurements part. I mean, just request from our hotline, just talk with the hotline and maybe get the measuring instruments part done for the 28 batch. H plus 4 over plus capital H becomes 7H over 4 after solving, okay? Yes, there's a part 4 in heat tube, okay? Now, pay attention. You can't take simple H as 20, okay? You can't take simple H as 20. It's not that you know half of it is submerged. What they are telling is you see as half of it is submerged. These are two entirely different statements, okay? If they tell the person knows that half of it is submerged, that means person purposefully put 20 centimeters underwater, knowing that the whole length is 40 centimeters. In this case, what happens is the person don't have that kind of idea. A certain length is submerged, some kind of a capital H. Then it appears at a depth of simple H. But randomly, the part above water and part below water that we see has become equal. So the person see or think that half of it is submerged. Two entirely different scenarios, okay? Clear? The person doesn't know that half of it is submerged. The person see half of it is submerged. When we refer to what the person see, that means for the apparent depth. So the person is comparing whatever above water with the apparent depth. Clear? The person is comparing whatever above water with apparent depth. Since they seems to be equal, he assumes that half of it is submerged. So if this apparent depth is simple H, this is simple H, this is simple H, but the real depth is capital H. Now the target is to find capital H. Okay? Clear? Entirely different scenario. They may change few words, the answer become entirely different, okay? Clear? They can change a few words on how they write the question, answer become entirely different, okay? Clear? So have to read carefully, okay? One of the main things we see when we check your papers in the paper class, okay? It's you are not reading a question properly, okay? You just write answers for whatever you have in your mind. That has become the main problem, okay? Even the good students, even the students who perform very well, who have good marks, okay? Even they, the most common issue is you don't read the question properly. You roughly go through the question, just like I do the discussion in the paper class, okay? I just go through the question quickly and do the question. I mean, because I am not going to get marks, okay? If I make any wrong decision, you would mention, okay? But even you guys write the paper like that, okay? You quickly go through the question, have a slight idea about what is happening, then start writing. So you write answers for whatever you have in your mind. That has been the main problem, okay? So I have to read things carefully, okay? Very carefully, okay? So I think, yeah, we can move to the heat session, okay? And remember next week, June 15th, and online students ask, yes, you can come. I always mention this. You don't need a team. We'll figure out the teams on Monday. No big issue there. A lot of online students are coming, so they don't have a team, so we can figure out a team there. So no big issue there. You can just come on, just be there at the location on June 15th, Monday, next Monday. So yeah, that's all for today. Let's move to the heat lesson. I can give you like 5-minute break if you actually need. If you don't have heat tubes, request, okay? Then we can continue with the heat session. Mali, do we have a separate link for heat class? I can't remember. I'll let you know which link to use, online students. Yes, right? Yes, right? There's a separate link, right? Yeah. So online students, you have to join from the separate link. You have to join from a separate link for the heat session, okay? Thank you. Go to the website and join from that separate link. Directly join from the separate link. Vale.